Welcome all for the today's session. So today we continue with the biostatistics module, and today's topic for the discussion is measures of central tendency. This topic is very important from the examination point of view because always this topic is tested in the examination. You will be asked the questions about mean, median, mode. Okay, so expect SBS on this particular topic. So what are the measures of central tendency? They are mean, mode, and median. Okay, so we will talk today about the mean, the median, and the mode. There are various types of mean that also we will see, but most commonly what is expected in the examination is the arithmetic mean. Okay, so by definition the it is the arithmetic average of the data as such. Okay, all the observations we calculate the arithmetic average. Then it is best used for the symmetrical data. And is it affected by the outliers? Yes, the mean is affected by the outliers. This is what is the disadvantage with the mean. Okay, then second is a median. Okay, median is the middle value of the data set when it is arranged in the ascending order. Then whatever is the middle value, that is the median. It is best used for the skewed data. Okay, while mean is better for the symmetrical data. Okay, and whether the median is affected by the outliers? No, median is not affected by the outliers. Okay, then third measure of central tendency is mode. It is the most frequent value which is coming in the observations. Okay, in the data set. Okay, most frequent value in the data set is the mode, and it is best suited for the nominal type of data. If you have a nominal data, then you calculate the mode. Is it affected by the outliers? No, it is not affected by the outliers. Okay, so we'll see one by one: mean, mode, and median. Okay, so mean, what is the formula for the mean? It is the sigma x divided by n, where sigma x is the sum of all observations. If you are given the 10 observations, you will add all 10 observations and then you will divide it by the number of observations, that is 10. Okay, so whatever the 10 observations are there, that you have to add and divide it by 10. So sigma x is the sum of all observations and n is the total number of observations. So this is what is the arithmetic mean we are talking about. Okay, then we will also see the types of the mean, and this formula is only for the arithmetic mean. Okay, so features of this arithmetic mean is that it uses all observations and it is the most common average. Okay, but disadvantage of this calculating the mean is that it is affected by the extremes of values. Okay, suppose your data set is here 20, 30, 40, 50, 60, and another you get 200, 300 values here and added to it, your mean will be affected. Okay, because most of the values are in this range, and suddenly you have got a one value of 250, so your mean will get affected. It will be pulled towards this higher side. Okay, so it is best used for the normal distribution or symmetrical type of data. If you have, then the mean is best. Okay, so suppose these are the marks of 5 students: 20, 30, 40, 50, 60. How will you calculate the average? Can you calculate the average? If you have got a pen and paper, as I already mentioned, that please be ready with the pen and paper. Yes, can you calculate and tell me? Yes, what is the average? What is the mean?
40.
So we will add all observation 20, 30, 40, 50, 60, that is around 200. Then total observations are 5. So we will divide the 200 by 5, that will be 40. Okay, so this is what is the arithmetic mean, and such type of calculations will be given. You will be given the birth weight of some data set. Okay, and then you will be asked to calculate. Okay, so a few important point to remember is that mean uses all the values which are given to you. So all the values which are given to you, that we are using, and mean is the balance point of the data. So it balances the whole data set as such. The next type, what we have seen, is the arithmetic mean. It is very easy to calculate, and practically speaking, only arithmetic mean concepts will be tested in the examination as far as calculations are concerned. But from concept wise, they may ask you other type of mean also. Okay, second is a geometric mean. Okay, so what is the geometric mean and how to calculate? It is actually the nth root of product of observations. Okay, it is the nth root of product of observation. What does it mean? You have to calculate the root, and which root? Nth root. and you have to calculate the product of observations. Suppose you are given the 10 observations. Then in arithmetic mean, we added all 10 observations. Here you have to do the product of all 10 observations. First observation multiplied by the second observation multiplied by the third observation multiplied, and all 10 observations you will multiply with each other, and then you will take out the 10th root of, because there are total 10 observations. Okay, this is what is the geometric mean, and this is useful when we are talking about some rates, like we are talking about growth rate, we are talking about population growth, we are talking about compound interest. Okay, because it is not it doesn't observations doesn't vary by some small difference. They have a some rate of growth. Okay, and that is why you need a geometric mean. Okay, so it is less affected by the outliers. So geometric mean is less affected by the outliers. Geometric mean is useful when values grow by multiplication and not by addition. Okay, so this is suitable where the values are growing by multiplication and not by addition. Okay, so formula for the geometric mean is the nth root of product of all observations. Okay, so suppose you are given the data set as 1, 2, 4, 8, 16. Then how will you calculate the geometric mean? 1 multiplied by 2 multiplied by 4 multiplied by 8 multiplied by 16, and you will take the fifth root of this. Okay, so product of all observation is 1024. Okay, 1024, and you will take the fifth root of this, and the final geometric mean will come as a 4. Now you calculate the arithmetic mean of this. Can you calculate the arithmetic mean of this? 8 plus 2 is 10. This is 5. 8 plus 10 plus 5 is 15 plus 16, that is 31. 31 divided by 5. How much is 31 divided by 5? It will come around 6 point something, 6.2. Okay, so when you calculate the arithmetic mean, you get 6.5. But when you calculate the geometric mean, you will get 4. Okay, so the values you are going to get is totally different. So you should know the which mean to use at which time. Okay, practically speaking, we use arithmetic mean always. Okay, but when geometric mean is to be used, when we are discussing or talking about the rates. Okay, when there is a growth rate. Okay, when the observations are multiplying. Okay, when observations in the data set are multiple, that time you go for this. Okay, and one thing you have to remember, arithmetic mean is always greater than the geometric mean. Okay, so you will have 6.2, which is greater than the 4. So okay, when you are given a data set and you calculate the arithmetic mean, that will always be higher than the geometric mean of that particular data set. Now third is a harmonic mean. Okay, now harmonic mean will be used when we are talking about rates, physics, and speed calculations. Okay, so suppose you are given a example such as car is traveling at a 60 kilometer per hour in one way, and it is coming back at a rate of 40 kilometer per hour in the return way. What is the average speed? Okay, here arithmetic mean, if you calculate, it will be 50 only, but actually when we are talking about rate, we can't use this arithmetic mean, we have to use the harmonic mean. Okay, so because we are dealing with the speed here, so we will use the harmonic mean. The formula for the harmonic mean is equal to n divided by sigma reciprocal of all observations. Okay, so here what we have to do, we have to do the reciprocal of each observation. Suppose there are 10 observations. Okay, so 1 divided by first observation, second observation, 1 divided by second observation, 1 divided by third observation. So all 10 observations, you will divide 1 divided by each observation. Then you will calculate the sum of that, and you will divide the total number of observation, that is 10, divided by this particular sum. Okay, so where HM is the harmonic mean, N is the number of observation, and sigma is the sum of 1 upon x, that is the reciprocal of each observation. Okay, suppose you are given the 2 observations, that is 60 and 40 in the above example. That means you have only 2 observations. Now how you are going to calculate the harmonic mean of this n? How much is n? 2. So 2 divided by 1 upon 60 plus 1 upon 40. Okay, 1 upon 60 plus 1 upon 40. Now you solve this 1 upon 60 plus 1 upon 40 and 2 divided by this particular answer, your answer will be 48. That is how the harmonic mean is calculated. Okay, so these geometric and harmonic mean calculations will not be asked, but the concept you should understand, and which place we are going to use when we are talking about the speed, we will use the harmonic mean. Okay, now let us go ahead with this second concept, that is the median. This is also very frequently tested concept, median. Okay, so median is actually the middle value after arranging the data. So it is the middle position value once you arrange the data in the order. Okay, so you have to arrange the data in the ascending order or maybe in the descending order also, whatever is the middle value. Now middle value, suppose if you have got a 100 observations, then what will be the middle value? Because there will not be a single middle value, there will be two middle values you will get. Okay, but if it is a 101 observation, then you will get the single value, because you will have the 50 observations on this side and 50 observations on the other side, and the middle value will be 51. Okay, so in that particular case, the median, you will have to have two formulas. One, when you have got a odd number of observation, and another when you have got an even number of observation. Okay, so how to calculate the median, this is very important, and which formula you are going to use, and they will ask you to calculate the median. Okay, so median is the middle value after arranging the data. Important thing is that it is the positional average. Okay, it is not the mathematical average what we are doing, it is the positional average, because we are arranging the data and whatever is the middle value that we are taking, and it is not affected by the outliers, while mean was affected by the outlier, but median is not affected by the outlier. And it is best used for when the observations are a skewed distribution. Okay, so if you have got a skewed distribution, in that particular case, if we go ahead and calculate the arithmetic mean, because of the skewness of the data, the mean will get affected, but we are taking here the positional average, that is why it will not get affected. Okay, so when you have got an odd number of observation, how you are going to calculate the median? Median is equal to value of n plus 1 divided by 2th observation. Okay, suppose you have got a 10 observation, that means 10 plus 1 divided by 2. Okay, so suppose you have got 11 observations, odd observations, 11 plus 1, that is 12 divided by 2, that is 6th observation. So you go ahead with the 6th positional value, that is going to be your median. So it is very easy to calculate if you have got a odd number of observation. Okay, you have got a 7 observation, then your fourth value, that is 7 plus 1 divided by 2 will be 4. Okay, so fourth value will be your median. Okay, so if you get the odd observation, it is easy, just use n plus 1 by 2 formula. Okay, so this is the odd observations. Okay, 12, 18, 25, 30 and 45. What is going to be the median here? You have got a 5 observations. What is going to be the median here?
N minus 1, 5 minus third observation, sir.
Yeah. Okay, so it will be 25. Okay, third observation, that is 25. Now in this data set, we have 12, 18, 25, 30 and 45. Okay, number of observations are 5. So position of the median position will be n plus 1 divided by 2, 5 plus 1 divided by 2, 6 by 2 is a third observation. Third observation is 25. So your median is 25. Okay, now suppose if you have got a even number of observation, then what formula we are going to use? You will take the middle two values and you will take the average of that. Okay, you will take the middle two values. Suppose you have got a 10 observation, then what we are going to do? You will do the n by 2. Okay, n by 2, 10 divided by 2, that is 5. And then you will take the next observation. Okay, so n by 2 plus 1th observation, that is 5 plus 1 sixth 5 and sixth value you will take, and you will take the average of that. Okay, that will become your median. Okay, so when you have got a median, calculation of the median for even number of observation, the formula is value of n by 2th observation plus value of n by 2th plus 1th observation divided by 2. So you have to take the average of the middle two values. Okay, so if you have got these data set of 4, 10, 20, 30 and 40, then there are 4 observations. Okay, so how will you calculate the this 4 observations divided by 2, that is 2, and the next observation 2 plus 3, that is 20 plus 20 and 30. The average of this, that will be 30 plus 20 is a 50. 50 divided by 2 is a 25. Okay, so this is what is the final answer, median as a 25. Did you get this particular concept when you have got a even number of observation, when you have got a odd number of observations? Is this clear to you?
Can you repeat even number of observation?
Yeah, when you have got a when you have got a even number of observations, just think n by 2. Don't remember this. You have to take the average of middle two values. Okay, average of middle two values, because if it is a odd, it is very easy. Half on this side, half on that side, and the middle value that will be calculated in cases of odd, n plus 1 by 2. Okay, so 11 observation plus 1, that is 12 divided by 2, 6. So you get a directly 6. But when you have got a even number of observation, then you will get a two values which are in the middle. Okay, then how will you calculate that two value? It is just you whatever is the number of observation, you divide it by 2. If there are 10 observation, you will divide it by 2, that is fifth observation, plus you will take the next observation. So fifth observation and sixth observation you will take, and you will take the average of these two. So what is the step? Step is the arrange the data in the sequence. Okay, order the data. That is the step number 1. Okay, then step number 2, how many total observations are there? If they are even in number, then you need 2 values to calculate the average. So you will take the n by 2. Okay, suppose there are 20 observation. 20 observation means 20 divided by 2. That is 10th observation and 11th observation you will take in that data, and you will take the average of those two. You got it now? Is it clear?
Yes, sir.
Yeah. And this is very frequently asked question. Practically you have to calculate. Only thing is that they give a very simple figures, but whether they are odd, hardly 8 figures they will give observations. Okay, so last concept is a mode. Okay, mode is the most frequently occurring value. Okay, whatever is the data set in which whatever is the value which is occurring more frequently, that is the mode. Okay, so this is useful when you have got a nominal data or the categorical data. So important point here, your data set may be unimodal, it may be bimodal, or it may not have the mode at all. This concept is very important because you may be given some data set and it may not have any mode, and they will ask you what is the mode. So one of the option is no mode, or your data set may have 2 modes, so it may be a bimodal. Okay, then just don't see at the highest value or the lowest more frequently value. You have to write both values as a bimodal. Okay, so for example, you have been given this data set 2, 3, 3, 4, 5, 5, 5, 6. Then what is the most frequently happening value? Here it is a 5. Okay, 5 has come 3 times. Okay, but if your data has got a 3 2 times, but if it is 3 times, then your this data set becomes bimodal. Okay, then mode will be 3 as well as 5. Okay, then we call it the bimodal distribution. Okay, so most repeated value here is a 5. So final answer becomes 5. Okay, so another example, your 1, 2, 3, 4, 5. Okay, here what is the mode? There is no mode here because there is no repetition of the value. That is why there is no mode. Okay, next, bimodal distribution. You have 2, 2, 3, 4, 4 and 5. This is the data set which is given to you. So you will have This 2 also happening 2 times, 4 also happening 2 times. It has got a 2 modes. 2 and 4 both repeat twice. So final answer, it is a bimodal distribution. So your answer will be 2 and 4 are the modes of this particular data set. Okay. So from examination point of view, you should remember, when you have got a symmetrical data, go for mean. When you have got a skewed data, go for median. When you have extreme outliers present, then also go for median. When you have got a nominal data, go for the mode. Okay. So median is best for the skewed data. Mean is affected by the outliers, and standard deviation uses n by 1. This we will see in the next session. Okay. So mean takes the everything. That means all observations are taken into account when you calculate the mean. Median is the positional average. So it is the middle of the data set. Then mode is the most repeated. Okay. Then geometric mean is the geometric mean grows. So when there is some growth we are discussing about, you go for geometric mean. Harmonic mean handles speed. So if we are dealing with speed, go for harmonic mean. Okay. Then order of means. Arithmetic mean is greater than or equal to geometric mean, greater than or equal to harmonic mean. Okay. This also we have seen with arithmetic mean and geometric mean. Same with the harmonic mean also. It is smaller than the geometric mean also, and it is smaller than the arithmetic mean also. Where AM is arithmetic mean, GM is geometric mean, and HM is a harmonic mean. Okay. So that finishes today's session on the measures of central tendency, that is mean, mode, and median. Okay. Now we have got certain questions, doctor, SBA questions. Now we will solve these questions together. Okay. So the first question, doctor, who wants to answer this question?
Yes,
Calculate the arithmetic mean.
the birth weight of 5 newborns in kg is given 2, 3, 4, 5, 6. What is the arithmetic mean?
6, 4.
20 divided by
5.
4. Option B.
Yes. Okay. So it is the mean is the sum of observations divided by number of observations. So all observations, and we are going to divide by the number of observations. Next.
A researcher records parity of women attending antenatal clinic. What is the median? 1, 2, 2, 3, 5.
So answer is 2, B.
How we are going to calculate here?
2.5 just divided by 5. No?
Median. Two formulas are there. Do you have even observations or odd observations?
Odd.
Odd. So here you just leave half on this side, half on this side. The middle value you have to take. Here you don't have to calculate anything. You have to calculate average only when you have got a even data set. Okay. So what will be your median here? Just look at the data set. Okay. 7, because you will be given less than 10 figure. Okay.
Yes.
Okay. So 2 on this side, 2 on this side, the middle becomes the, provided your data is arranged in the order. Okay. So arranging the data in the order is the most important thing. Okay. So here median is going to be 2. Okay. That is the middle position. So here the formula is n plus 1 divided by 2. Okay. Third observation. Okay. Next.
The duration of labor in hours in 4 patients is 4, 6, 8, and 10. What is the median duration? 6 plus 8.
So number of observations are even.
Even. 4 plus 1, 5. Divided by 2.
So formula is n by 2 plus next. N by 2 is what? 4 by 2 is 2. So second observation and third observation average. Okay.
6.
2. Option B. 7.
Yes, 7. Okay. 6 plus 8 divided by 2. Okay. Dr. Monica, any doubt?
No, sir.
Clear, no?
Yes, sir. Yes, sir. Clear.
Okay, yeah. So no confusion now for such problems. Okay. Next, Dr. Monica, solve this now.
The following Apgar scores are recorded: 7, 8, 8, 8, 9, 10. What is the mode? Mode is the most frequent. No? So 8 is the answer, so B.
Yes, it is the most frequently occurring observation. 8 occurred 3 times. So mode is 3. Next.
A study records hospital stay, that is dates, is 2, 3, 4, 5, 20. What is the arithmetic mean? So it is so it is 6.8. C.
Yes, yes, 6 point something is going to come 6.8. Okay. So here you notice that it is there is an outlier. That is why this has become 6.8. Otherwise, it would have come somewhere between 3, 4 or something like that. Okay, because observations are 2, 3, 4, 5 only. But now it has changed. Okay, so outliers will always affect the arithmetic mean. Okay, so larger outlier pulls the mean upward. Okay, go ahead with the next, Dr. Monica.
A researcher studies duration of hospital stay after surgery. Data are highly positively skewed. Which measure of central tendency is the most appropriate? A mean, B median, C mode, D range, E variance. So the answer is B median.
Why? Because it is highly skewed data. Okay, median is preferred in a skewed data because it is less affected by the extremes of value. Examples are income, ICU stay, waiting times, hospital stay duration, etc. Next, doctor.
In perfectly normal distribution, which statement is correct? Mean is more than median is more than mode. Mean is less than median is less than mode. Mean is equal to median is equal to mode. So answer C, mean is equal to median
Yes,
is equal
because you are dealing with the normal distribution. Okay, so mean is equal to median is equal to mode. So in symmetrical normal distribution, mean, mode, and modian coincide at the center. Okay, next question.
which measures of central tendency represents the most commonly occurring observation? A mean, B median, C standard deviation, D mode, and E variance. Sir, answer is mode.
Yes, D mode answer. Okay. So most frequently occurring value, mode is especially useful for categorical data, most common symptom, most common blood group, most common diagnosis. So if you get such kind of, you go for mode. Okay. So that finishes today's topic of measures of central tendency. Thank you.